Welcome everyone. If the pre-registration list is to be believed, we're going to have a nice large crowd and a very good one in terms of the quality of the attendees and the importance of the organizations that you represent in the development of a biomass economy in the United States. So I'd like to thank you all for attending, and I really look forward to an interactive and an excellent session today. I'd also like to remind everyone, when you have a moment, there are sign-up sheets for the breakout sessions this afternoon. Please do enter your name on your breakout session of preference when you have a chance. So we're here to talk about opportunities and obstacles in large-scale biomass utilization. And because this is sponsored by the Chemical Sciences Roundtable, in the breakouts this afternoon in particular, one of the questions we'll ask is, what is the role of the chemical sciences in developing that? So chemists and chemical engineers and other people that receive and utilize chemistry training in their work. There we go. So the challenges of scale in biomass production, obviously on the feedstock production, the crop side of things, we want to increase yield, we want to decrease inputs, we want to make things easier to convert, we want to expand the range where we can produce these materials. In conversion technology, we need increased yield and selectivity, we want to reduce the capital required, make new and better products. You know, we know how to make ethanol and biodiesel and a few other things, but let's add to this slate of products. But that's not really what I want to focus on today. There's a lot of good work going on in those areas, and in fact, some of the people that are at the forefront of that are going to be our presenters or in the audience today. But even if we make progress on those individual segments, the whole supply chain for biomass and its products is only going to be as strong as its weakest link. So I'd really like to focus our thinking and our conversations today on the barriers to scaling everything up. And that doesn't, I want to be really clear, that doesn't necessarily mean that we're going to be scaling up individual processing. The processing of feedstock, for example, could remain relatively small scale, but we have to bring the overall market to a large scale to have meaningful impacts on things like the economy, on the use of crude oil, and on the emissions of greenhouse gases. So this includes things like the limited supply that exists for conventional feedstocks, issues in feedstock harvest and collection, feedstock transportation and seasonal storage, operating each link in the supply chain at an efficient scale, and then eventually transportation and distribution of both intermediates and finished fuels and products. So one thing I'd like to talk about is the carbohydrate supply problem. If we took all of the cereal grain in the world at theoretical maximum yield and made it into ethanol, all the corn in the world, all the rice, all the wheat, all the barley, and everything else, the millet and the oats and every other cereal grain in the world, the total we would be able to make is about 14 million barrels of oil equivalent per day. That's a lot of oil, but what the petroleum industry does today is 85 million. So less than 20%. If we took all of the cereal in the world, we had nothing left to eat and very little left to feed to animals. So obviously on conventional carbohydrates, there's a very serious limit on the kind of an impact we can make on the fuels business. So I won't try to steal too much of Bryce Stokes' thunder here, but hopefully Bryce will be talking about the lignocellulose solution. Get away from cereal grains, away from conventional carbohydrates, and utilize lignocellulose, both wastes that exist today and on-purpose energy crops, in order to make real serious volumes of fuels and chemicals and energy without impacting food supplies. Another problem I call the tyranny of distance. The density of crude oil and natural gas production is really wonderful. It's very expensive to drill those holes in the ground, but once you've drilled the holes in the ground, you can get massive amounts of production from one little pipe. And so you're able to operate things at a very large scale without too much trouble. Biomass is very different. It's sparsely distributed. Even the most high-yielding energy crop requires many, many, many times the area of an oil field to produce the same amount of equivalent energy. And this is a little chart that Spencer Swayze at Ceres put out. You can move the sliders. How much biomass do I want in tons per day? What's the yield per acre of biomass, and what percentage of the area around the conversion plant do I think I can draw biomass from? When you adjust those three sliders, it comes up with a radius. How far on average are you going to have to transport things to get it to the gate of your conversion plant? But the answer tends to be, if you want to operate at anything like the scale of a petroleum refinery, you have to carry things too far. So we need to figure out some way to work with that tyranny of distance. And again, this may be in Bryce's talk, so